Okay, so this is an exam 3 review for differential equations. And so we're covering chapter 6. Let's say sections 6.1 through 6.6 and 5.1 and 5.2. Okay, so just as a reminder, 5.1, we do a review of series and power series, right? And so in particular, be able to look at the radius of convergence, compute it, and also the interval of convergence. We'll do an example of the difference between those. 5.2, we're solving the dE using a power series or a series solution. Okay, and in chapter 6, of course, it's all about the Laplace transform. Good. So I'm going to pause. Before I pause here, let's just talk about the exam generally. So we'll have 90 minutes for the exam. I try to write the exam to be about the same length as it would have been in class, which is about 50 minutes. But because we're doing all this stuff online and all that other stuff, sometimes it does take more time. Let's see. So it'll be open book, open notes. I would have a calculator handy, and then you can use the website, class website. Okay, no other computer programs or websites, right? In other words, you're not allowed to use a computer algebra system like Maple or Mathematica or Wolfram Alpha, okay? But you are allowed to use a calculator. Good, okay. Yeah, okay, I think I'll pause here and we'll just start writing down a few random questions. Okay, so here's an example. Find the interval of convergence if we have the sum going from 1 to infinity of -1 to the n, 2 to the n, x plus 3 to the n over n. So let's use the ratio test. And take the absolute value of the n plus first term divided by the nth term, right? And so that's going to be, I guess, it depends on whether the term includes the x plus 3 to the n or not. I guess in the notes we didn't do that, but assume that that does include that, so I don't have to rewrite it. Okay. The -1 to the n is not going to play a role at all, right, in the absolute value. So the 2 is already going to be positive. And then be sure and put absolute value bars around the x plus 3, right? Good. And then that's divided by n plus 1. And then we'll go ahead and multiply by the reciprocal, so that's going to be n over 2 to the n times the absolute value of x plus 3 to the n. Okay. And so now, I guess we can go ahead and take the limit now. As n goes to infinity of, let's see, we'll have 2 to the n plus 1 divided by 2 to the n times n over n plus 1 times the absolute value of x plus 3. Good. So this is just going to be equal to 2. This is equal to 1. And so we just get 2 times the absolute value of x plus 3. The result of the ratio test is we want that to be less than 1, right? So therefore, the absolute value of x plus 3 must be less than 1 over 2. Good. So the radius of convergence is 1/2. Good. Now, x plus 3 is either equal to 1/2 or x plus 3 is equal to -1/2, right? And so here, maybe we'll put a quick number line just to So our series is centered at minus 3, right? And you go 1/2 unit either way. And so, how do I want to write that? Minus 2.5 and minus 3.5. Okay, so now if I put that back into my series, that's 2 to the n, x plus 3 to the n divided by n. Okay, if x is equal to minus 2.5, what happens? This becomes a 1/2 to the n. The 2 to the n's cancel, and you're left with minus 1 to the n. Sorry about the sloppiness there. Minus 1 to the n over n. This is an alternating harmonic series, so that converges. Good. And then what happens if x is equal to minus 3.5? If x is minus 3.5, then we get minus 1 to the n, 2 to the n, that's minus 1/2 to the n divided by n. You see what happens now? The 2 to the n's are going to cancel, but the minus 1 to the n's becomes just a positive 1, right? It's minus 1 squared. And so this is just going to become the sum of 1 over n, and this diverges. Good. So therefore the interval for convergence is going to include the point negative 2.5, but exclude 3.5. Good. All right, so I'll pause here and we'll write down another question. Okay, let's just solve the differential equation using the Laplace transform. So here we go. Now when you're taking the Laplace transform of these, remember that the Laplace transform of y is going to be our capital Y of s. That's how we defined our Y of s. Okay, and then for the first and second derivatives, we need a formula. If we have Laplace of e to the minus t, that's just right off the table. Okay, and now so for these, let's remember that the Laplace transform of y double prime is s squared y of s minus s y of 0 minus y prime of 0, and Laplace of y prime is s times y of s minus y of 0. Okay, so you can kind of see that pattern there. So in this case, that's going to be s squared times y of s minus s times 0 minus 1, and this one will be s times y of s minus 0. Good. So we plug those in, and we end up with s squared minus 2s plus 2 times y of s, with a leftover of a minus 1 there that I'll shift over to the other side. Good. And now I need to skip around my notes. I'm doing the thing that I told you guys not to do. Oh, that's okay. Y of s equals 1 over s plus 1 times s squared minus 2s plus 2 plus 1 over s squared minus 2s plus 2. Very good. Alright, so now we see here we're going to have to use partial fractions. Also, I should check to see, does s squared minus 2s plus 2 factor? How do you do that? You can just set it equal to 0 and try to solve, right? Oops. And so if we complete the square real quick, right, that's going to be s minus 1 squared equals minus 1. So s is equal to 1 plus or minus I, right? And so that means that it's irreducible. And so therefore we can just go ahead and do our regular routine here for partial fractions. Okay, so that's a over s plus 1 plus b s plus c over s squared minus 2s plus 2. And it doesn't take too long to find your constants. I'm just going to go ahead and write them down since we're Getting a little short of time here. So that's going to be 1/2 times, well, I'll put a minus 1/2 here. And then that'll be an s minus 2 in the top, s squared minus 2s plus 2 in the bottom. Good, okay. And don't forget that we still have that other one hanging out there. Good. Okay, so our y of s now is 1/2 times 1 over s minus 1/2 times s minus 2, s squared minus 2s plus 2, plus our 1 over s squared minus 2s plus 2. Good. Let's see. We had already completed the square on that, so we know that that's s minus 1 squared plus 1, right? Good. All right, so now it looks like we're ready to go. This is 1/2 times 1 over s minus 1/2 times s minus 1 over s minus 1 squared plus 1. And then I have another minus 1 over s minus 1 squared plus 1, right? Keep that all with the 1/2 there. And then we'll have a 1 over s minus 1 squared plus 1/2. I guess we could have combined these two terms, but we will in a second anyway. Let's see, I don't want to rush through the rest of this, so maybe I'll break this problem right here, and then we'll finish it up in the next video.